Hello, everybody. Thanks for joining us today. I'm Nick Rago, I'm Field CTO with Salt Security. Welcome to this presentation and discussion on Better Together, protecting business transactions through API security with Salt and AWS WAF. Before I introduce my fellow presenters, a little bit of backdrop about the presentation and the discussion today. It should not be a surprise to anyone at this point that AWS is where many of the world's APIs live and breathe, and that those APIs power and enable many, if not most, of the apps and the business services that we all rely on daily. We are well aware of this at Salt, and that's why AWS is a strategic partner to us. We've heavily entrenched in a wide array of AWS partner programs. The latest was announced last week, where we announced that Salt is now an AWS Web Application Firewall or WAFF Ready partner. What this basically means to the masses is that our technology has been vetted by AWS solution architects to ensure it integrates with the AWS WAF seamlessly and also adds additional security value. So today, the Better Together discussion is focused around how the AWS WAF and Salt's API security platform, when they're used together, can more effectively and quickly reduce API security risks. So, to convey that message effectively, I need smart people from AWS to help me. And that brings me to my co-presenters here. So I'm joined with Matthew McCarty. He's a senior security consultant from AWS, and Sanjeet Kandako, who's a senior edge specialist from AWS. So Matthew and Sanjeet, if you don't mind just taking a minute or two and talking about what your role entails at AWS, the product and the products and services you touch, I think that will give good context and also help for a better interactive dialogue with the folks online here. So Matthew, if you could go first, please.
Sure. As Nick said, my name is Matthew McCarty. I'm a senior security consultant with AWS, and I provide technical and advisory capabilities in terms of whether they're people, processes, or even the technology, specifically to things such as cloud security architecture, security controls, and team development and training. And I do that for enterprises throughout the United States, but mostly within the United States Central region. It's good to be here with all of you.
Thanks, Matthew. And Sanjeet?
Sanjeet Kandaka. I'm a senior edge specialist solutions architect. In my role, I work with customers across different verticals and different industries to help them accelerate their applications and protect their applications through AWS CloudFront and perimeter protection services.
Great, Sanjeet. I'm very honored to have you both joining us today and to walk through this, and to sort of just highlight and illustrate the announcement that we made last week with the two companies. So what I wanted to do today is a couple of things. Is that first, we're going to kind of make this interactive, and I'll treat this more as where we can as more of a panel discussion and not just throw blind slides up in the air here. But a couple of things that we do want to cover. First, we do want to cover the sort of notion of what API security is and the fact that it is a team sport with a lot of different disciplines. And we'll go over a little bit about that. We'll talk about the AWS WAF, what it is, what it provides you with, the threats that it gets in front of. We'll talk about new security challenges specific to APIs, Salt, why we're even in business in the first place, and the threats that we help you with from an API security perspective. And then, why we're all here today is the Better Together story. When you put these technologies together, how they better help you reduce API security risk. And then, time permitting, we'll take some time for questions as well. So starting off here, I spent a lot of time really talking to CISOs and customers and analysts and partners about some confusion in the market about what API security is. At the end of the day, API security is a strategy. It is not a single platform. It's not one technology or product that you buy off the shelf that's magically going to reduce risk for everything that is related to APIs. It requires strategy that recognizes and uses technologies across a wide variety of disciplines, and each one of those technologies and tools in those disciplines have to have appropriate competency in order to be able to reduce risk effectively. They all play a key role in reducing risk where APIs are. And that's why you see a lot of this team that's up on the screen here between the WAF and gateways and IDPs and CDNs and workload management and posture management, testing, logging, all of this, and all of these play key roles in a good API security strategy, and you're only as good as your weakest link. and with a lot of these type of technologies. That's why most organizations typically look for best of breed technologies and key competencies in every one of them. We're going to talk about a couple key competencies in security disciplines today, really focused on the AWS WAF and then the Salt Security API protection platform. We're going to focus on what the technologies do separately, but also the added value they give you when you use them together. So, Sanjit, when it comes to web-based application security, including APIs, WAF is one of the first things that customers consider as a first line of defense. It by itself does a lot to reduce risk and adds a lot of value there. The interesting thing, though, is that many organizations I talk to, they're unaware and unfamiliar with the AWS WAF technology and what it's capable of. I think a lot of times it's getting written off as it's a cloud-based technology. It's something that AWS just threw in and has limited capability. And that's not true. So what I was hoping you could do is just give a little bit of a brief overview of what the AWS WAF is, what it provides in terms of threat protections and functions, and what it's actually capable of.
Sounds good. Thanks, Nick. So in terms of as more and more applications today go public or go to the internet, they're exposed to a wide variety of attacks. Some of these commonly known external threats are either could be denial of service, which is making a lot of requests or clogging up the bandwidth and tying up valuable resources, especially for dynamic applications. There are also attackers who will more focus on application vulnerabilities. This could be zero-day vulnerabilities, or it could be cross-site scripting, application-specific or programming language based attacks, or it could be bots, which could be creating a very resource scarce for your customers, tying up valuable inventory or tying up other workloads. So that's where Web Application Firewall, which is a cloud-based application firewall, comes into picture. WAF protects against these common known threats, such as DDoS or application vulnerabilities. It could be covering the OWASP top 10 rules or vulnerabilities, or it could be detecting these bots, which are essentially tying up these resources. So they affect your application and workloads or sites they affect your availability, they compromise the security, exposing your applications, or they consume excessive resources. AWS WAF can cover a wide variety of services that are deployed on AWS infrastructure. It could be your Elastic Load Balancer. It could be your CDN configurations like Amazon CloudFront, your API gateways, or your applications like Amazon Cognito, or applications built on AWS AppSync. When we talk about what WAF covers, WAF covers application vulnerabilities. Like I said, you can implement security automations to analyze your logs and include IP allow lists or deny lists. There is also a marketplace of third-party managed rules, which covers common application vulnerabilities that are not included in the AWS managed rules. You can protect applications from DDoS services with rate limiting rules, or you can build your own custom rules as well and include custom header insertion and labels. So there's a wide variety of flexible rule configuration options available with AWS WAF to deal with these threats that we talked about. Some of the other areas where AWS WAF can help protect these applications is with intelligent threat mitigation. What this includes is that commonly known bots or specific targeted bots, use of account takeover prevention, which compares your login attempts against a known list of compromised login credentials. There is CAPTCHA and challenge integration, as well as ATP and mobile application integrations. So that's a sort of a summary of what AWS WAF does and what kind of attacks it covers. However, there's also one crucial component of web applications and applications that WAF could use additional configuration. That comes to API security. WAF rules by themselves deal with a sort of a static workflow where you do not have a historical context of what a certain application or a user is doing against a specific API that you're making it available through the internet. And that's where API security is a very important focus, where you want to understand what your API does, the business logic. And that's where I will hand it back to Nick to sort of explain how Salt complements AWS WAF.
That's great, Sanchit. Thank you. I did actually have a couple questions for you, and I think a lot of times folks overlook the value of the WAF in terms of the value that actually gives from an API security strategy standpoint, because it does, we have to think of this as security in layers, right? And that at a front layer, this actually thwarts a lot. We don't want to have API transactions going around the WAF and relying on further downstream technologies. This is an important technology that, from a frontline defense, gets in front of a lot of attack types. Would you agree with that?
Yeah, exactly. And when we say, more and more applications are going worldwide and global, and so you're exposed to not just a distributed variety of attacks, but then there's also attacks that against API endpoints that consume a lot of resources, and they could be crafting their requests in such a way that you want some dynamic or a system which is capable of learning these API requests and responses and understanding and tying that to business logic as well, and use some usage patterns around the API.
Great, and you're setting me up good here for the upcoming slides. Two other quick questions. You mentioned that there's a marketplace of rules that customers can leverage with the AWS WAF. Who's writing those rules? Who's populating them? Is that just the community of all the AWS users that are out there, WAF users out there, sharing their rule sets with each other?
No, this is more specifically around, there is a AWS managed rules, which is constantly, it takes input from AWS security research, from our security engineers and security experts. The marketplace of rules is actually from our partners who actually have their own security infrastructure and security experts who are constantly looking at some of these use cases that WAF does not cover. And they're actually complementing this with a rule group that can easily be integrated into AWS WAF.
Okay, great. That's really important. And then we had a question come in from the audience asking about what the WAF can actually block. Can the AWS WAF block just IP addresses, or can we attach to other things in request parameters to have more specific blocking capability?
Yeah, WAF usually covers commonly known application vulnerabilities. This could be application vulnerabilities identified by the Open Web Application Security Project, OWASP Top 10 vulnerability classifications. It could be IP addresses, either allow lists or block lists. It could be cross-site scripting. It could be programming language specific rules, sort of like PHP rules or Windows environment rules or Linux, Linux environment rules, and so on.
Great. Thanks, Sanchit. That was really, really helpful. And to your point, what I wanted to talk about next was what's different about APIs. So again, security and layers here, the WAF, very important part of overall API security strategy. But there are different challenges that APIs also give you that a technology like the WAF that Sanchit just went over are not architected to basically be able to flush out and protect you from. So when we talk about what are the different challenges that APIs present at the application layer to organizations, I usually break this down into 3 buckets when I talk to folks. And the first is around control, and this notion of organizations are really struggling today with the idea of, I don't even know what I have out there. I don't know what to protect. Am I even sure traffic's going through the WAF? Do I even know where all my APIs are? Are they documented? I have 5 different development teams building microservices in 5 different places in 5 different ways. How do I know about them? How am I comfortable? Am I comfortable with the security posture? Are we securing them all the same way? So these are things that organizations are very, very worried about. The other thing about this attack surface is it's not just APIs that organizations are developing, it's APIs that are getting deployed as part of packaged applications, open source applications, low code, no code systems that are being deployed inside organizations that also are becoming attack surfaces that need to be looked after. The other piece regarding control that's been making it so difficult for organizations is this notion of the attack surface is constantly changing. We just last quarter put out our state of API security report, and the respondents coming back, you can take a look at the chart over here on the left part of the screen, well over half of them saying at least monthly their APIs are getting updated. So what I knew last week or last month could be completely different from a business logic and a functional standpoint in the APIs that I even know about. So this has been a real struggle for organizations. The second piece is this idea of context. So Sanjeev, you talked about this notion of, listen, I have the WAF in place to be able to attack my known attack patterns, my known type of cross-site scripting, SQL injection, code execution attempts, things like that. I can thwart those bad behaviors and transactions right out of the gate. The issue with APIs that Sanjeev mentioned before was this notion of a lot of the attacks are business logic based. It's the next layer of attack type where the attackers have figured out from a business logic standpoint, I'm going to take advantage of some type of vulnerability, either to take down services with a low amount of traffic, or I'm going to exfiltrate data by manipulating transactions to induce some type of negative behavior out of an API, some type of business logic flaw that was left behind. The problem with that is there is no signature to attach to. Every endpoint that has this type of vulnerability associated with it represents its own zero-day attack. So these attack types and these transactions look legit, so they're very difficult to discern from all the other noise and transactions that are taking place. So again, this notion of these low and slow attacks and the types of attacks have really changed. The last piece is this idea of coverage. And folks will say, well, let's just focus on testing and we'll double down there. The problem that organizations are running into on the testing side is when we're talking about business logic flaws, and that's where a lot of API attackers are attacking at the application logic level, at the application layer, it's very difficult to flush this out with automated testing inside the pipeline. A lot of these things are typically found with in-depth pen testing where the developers are interviewed. The problem with that is APIs are updated, as you saw, so frequently, and they're so vast in an organization with a lot of transformation and API first design architectures that we see today, that it is very difficult to get those low-level tests done or get that interview done with the developer to understand what is the expected behavior. Is this supposed to respond back with somebody else's data? Is that an expected behavior or unexpected behavior? So again, because of all this, you have to assume that when we're pushing APIs out the door, that there are vulnerabilities in production that are unavoidable. And your best defense, your best ability to reduce risk quickly and effectively and to minimize risk is to ensure that you have proper detection in place to detect when something bad is happening. And I'll pause here for a second because Matthew, in your practice, how have your customers addressed these application layer challenges that APIs are given? I guess, are they even talking about them? Do they even know that they exist in the first place?
Well, so in my practice, one of the first things that we try to do with the customer is to get an inventory of the assets that they have. Most companies are generally pretty good at this. They're good at knowing how many cloud assets they have. But when I ask them about how many public-facing APIs they have, I almost always get a deer in the headlight look. I mean, it's an area that's just often overlooked. So when you talk about control, one of the great things about the cloud the things that it's brought us is agility, the ability for developers to develop with speed. But then that has become a problem with this API sprawl because companies and enterprises, they just don't have a handle on where those APIs are, what they're doing. And, those companies that do have an idea, many times they'll hire professional services from AWS, people like myself. And as part of my work with the AWS developers, I review a lot of code for code quality and for best practice implementation. And we do this in an attempt to make sure that we deliver to the customer the best quality code that we can. But like you said, there's limited time to do this, and business logic flaws, which APIs may contain, are sometimes the hardest things to discover. So when one publishes an API for production use to the public, we're also, again, taking risk, and we're publishing it to all of the bad actors that are out there. But by doing this, we're essentially crowdsourcing our vulnerability discovery process, whether we like it or not. So with a tool like Salt, we're able to take that person's evil genius and make that and put that to our advantage. So when they find a business logic flaw, we find it too. And then, of course, we're able to patch it by virtually patch it through the integration with the WAF, the AWS WAF. And then we can take that information and give it to our developers. And so, those are every single one of these, the control of API sprawl, this area where the attacks have changed a bit. People are really going after these APIs because they know there's business logic flaws in them. All the way to testing, there are difficult problems to solve. So with a tool to enhance our visibility and over this problem, like Salt, we're able to close some of those gaps.
That's good. That's good insight, Matthew. Yeah, I, especially on the testing side, when I work with a lot of DevOps folks, they typically say we can count on maybe testing 20, at the best case scenario, 30% application business logic permutations before an API or an application goes out the door. So they're basically saying there's just a whole heck of a lot we don't know what the app is capable of from a business logic vulnerability standpoint or a negative function standpoint when that API goes out the door. So yeah, I'm seeing that same thing in those struggles every day here.
The complexity that you see with APIs is a perfect solution for machine learning.
Yes,
so it's beyond human capabilities. So.
Yes, and the timing I think was perfect with the advent of ML and AI and what we're able to do today. And again, obviously the company I work for here and Salt and the technology that we put forth, a bit ahead of its time, almost 5 years ago now. These are the typical attack types that we're getting in front of them. So when we talk about these challenges from an API standpoint, these application layer challenges that APIs the APIs are bringing to the table now, these are sort of the simplified attack categories that we're seeing, adversaries or malicious users or attackers have success in. And we've seen, I'm not going to put logos up on the screen. You can go and Google in the press and see that you're going to see a lot of the breaches that we've been seeing in the press are companies with very, very big cybersecurity budgets and cybersecurity programs. They test everything. They have everything from a layered security standpoint, in front of their doorways, and they still suffered API breaches. And these are the typical categories why, and they're all related to the challenges we talked before. The first is this sort of lack of API visibility and governance. We saw a major Australian telecom company last year get hit with this. They didn't know an API was exposed with no authentication out on the internet. Someone made a mistake. An attacker found it, was able to siphon tens of millions of customer personal information and account records out of that interface. We see, abuse and misuse potentials. This is where attackers are taking advantage of developers who have built APIs who are doing exactly what they're supposed to be doing, but just did not think of sort of that nefarious mindset and had an attacker in mind when they developed it. There was a bike company who, great example of this, their bikes were phoning home over to the mothership, their exercise equipment, doing exactly what it was supposed to be doing from an API standpoint. But again, the API was obfuscated. They didn't think that an attacker would ever find it or use it or could be used maliciously. Attacker was able to siphon all sorts of personal information out of that API, profile information out of that API. Business logic flaws are still the most prevalent attack type that we're typically seeing today because, as I mentioned before, APIs go out the door and organizations just have to accept the risk that there's a whole heck of a lot we don't know they're capable of from a negative behavioral standpoint. And we see these type of attacks in the press all the time. One of the big ones was one of the big most social media giants. Actually, at this point, you can probably look at all of them. They all have examples in the press. But one of them experienced the breach over 18 months long. or an attacker figured out, hey, if I massage two microservices, one of the, two UI microservices in succession, I'm able to actually, they were able to find that a developer left a bad Easter egg behind where another user or viewed as entity, a access token, a non-expiring access token was being left behind. So a user was able to use their own credentials, write a script, and essentially harvest information low and slow over 18 months. Tens of millions of user accounts were essentially in use on the dark web, was essentially breached because of this, because the access tokens were essentially sold. The last thing is we're seeing stolen credentials and social engineering. This is another big threat where a lot of organizations are really, really focused on now. This is, I'm training my employees, don't click the link, don't click the link. It's too enticing, I click the link. Now somebody has access to our network, they have access to our source code repository. Once I'm in that repository and I see source code and maybe there's a static API, a privileged API key that maybe a mobile app is supposed to use, phone home back to the mothership. Once I have that key, what do I have in my detection arsenal to be able to actually detect that that key is actually being abused if the user or the transactions are being done with an authenticated and authorized, privileged API key? That's supposed to be a protected key. And this is a big, big concern for a lot of organizations is, do I have anything sophisticated enough to detect that? So from a SALT perspective, we'll kind of shift a little bit more about the SALT technology and bring the two together here. These are the threats that we are focused on thwarting and getting in front of for organizations. This is our security discipline. This is where we are focused as a company from a technology standpoint. And it's really focused in a couple different value areas. The first, if you kind of take a look at the first couple threats and attack categories here, is this notion of API inventory and posture management. So, it's the improvement of poor Matthew having to comb through thousands of elements of source code to find HTTP endpoints and inventory them, giving organizations the ability to do this at scale, integrating with all the technology assets that they already have, but not just giving you an inventory of APIs, but also giving you the ability to understand and creating a platform that provides API security posture governance. I want to make sure that a developer never uses a user ID in a non-guessable format. Has to be UUID based. These are now governance controls, security governance controls at the API layer that I'll be able to detect for and be able to enforce. Also, documentation. I don't know, Matthew, in your practice, if you see a lot of documentation issues, but from where I sit, when I ask organizations, it probably goes hand in hand when you ask the question about, do you know where your APIs are? The second I ask them is the ones you know about, are you documenting them well? Do you have a portal where you're kind of keeping a source of truth? And the resounding response is no, we don't, or we don't trust the documentation. I don't know if you're seeing a lot of that on your side as well.
I think it's the latter. That it's I see a lot of documentation, but a lot of the documentation is either old, outdated, or it's not accurate in terms of
it's not accurate.
What that API is doing today as opposed to what it was doing yesterday.
So that's another big problem that we were really focused on is, okay, the docs that we have, are they valid to give that drift analysis? And if not, can I create the documentation and enrich them in such a way that I can use them elsewhere and enrich other security tools like testing tools to be able to do more business logic testing. I'll talk more about that in a minute. The threat protection, to your point, Matthew, before about the advent of AI and ML and the capabilities there, this is a whole new category in the security space. This idea of, can I detect nefarious activity against my APIs? Can I discern between a malicious user and a malicious anomaly and detect reconnaissance against my APIs in a trustworthy way, in a dependable way, versus a developer who's making integration issues and testing issues and having issues there and making some errors and some anomalies there. That is, this is the technology that a lot of organizations, this is the safety net that allows them to quickly reduce risk with the least amount of friction. It's the insurance policy for a lot of organizations so that they have more confidence that I don't have to find every business logic vulnerability because I have this technology behind me in production that will be able to discern when there's something bad that's happening. And we'll talk more about the WAF integration in a second, how that actually helps the block there. But to Matthew, the point that you mentioned before is, how do I take what I'm learning in production and actually make things better? How do I fix and build better APIs with that? So from a product and a platform perspective, again, just kind of drilling a little bit deeper into the SALT platform, what we actually do and what the product does from a value in a security risk reduction standpoint. The technology in the platform is all based on looking at traffic. And, Sanchit talked earlier about sort of the WAF and the idea there, and that's in line and how it's inspecting traffic. This is a technology that's asynchronously looking at the traffic. So it's typically not in line. But takes a feed of your API traffic. And it does it from a variety of different ways. And if I kind of overlay some of the different AWS technologies, and I'll go one level deeper here in a couple minutes, from ALB's API Gateway, CloudFront, Kinesis, the CloudWatch integration, and all your workload integrations, EKS, EC2, Fargate, ECS. What we're doing and what the platformers do is it's basically taking a copy of traffic and it's extracting bidirectional API metadata out of it, descriptions of the traffic. So we look at traffic, we essentially take metadata, descriptors of the traffic. It's a post, it's got 10 parameters. Parameter 1 is a social security number. It always matches response parameter 4. Here are the header elements, here are the data types. So a lot of metadata that's being captured about each request and response. The actual payloads themselves are discarded. We're capturing not just posture information and structural information, but hundreds and hundreds of behavioral attributes as well. And we're feeding this into the industry's largest cloud scale API metadata lake. The advantage of doing this, holding months and months of this metadata, is a few. First is that it gives us a very, very diverse data set to run the industry's most diverse ML and AI models against. And this is sort of three legs to sort of the ML and the AI technology that we use here, three different ones, and I'll talk about them as we go through here. But the interesting thing here is, we're taking the largest data sampling, the largest API metadata lake. We're running a very, very diverse set of modeling and behavioral models against them, not just looking at minutes of transactions, but seconds, minutes, hours, weeks, months of behavior and beyond. And the advantage of doing that is then we take a look at this data and we have this sort of network effect where we're actually able to take a look at everything and learn from all of our other customers' traffic as well. And I'll talk more about that in a second here. The platform has actually analyzed trillions of API calls to this point today. Again, these models have been running for about 4 years out in the wild. We're constantly improving them. And the payoff is essentially this. The first, the ML and AI technology I talked about is this notion of a neural network or deep learning ML technology that learns what an API actually is. So this is important because from a detection standpoint and a posture detection standpoint, whatever SALT actually shows you in your inventory with this technology is accurate, and you can actually have some confidence that what we're showing you is actual an API. We're able to identify all the dynamic elements and coalesce everything into single endpoints for you. Doesn't seem like a big deal, but if you don't do this, picture a large organization with tens of thousands of endpoints. I don't want to spend weeks and months coalescing, going through an inventory to try to figure out what's actually accurate and what's not. So again, that deep learning network, that neural network is important to be able to do that. The other two layers of ML and AI that we're actually using are on the behavioral threat protection side, the protection side of the house. And that is the ability to first detect anomalous activity, a wide range of anomalous activity. And that's, again, all these different behavioral models that we're running with cloud scale compute and cloud scale data. The third level is once I have these models of each and every endpoint that, that's in my environment, what's normal, what's not normal, and be able to detect against anomalous activity, I don't want to blow up my SOC because well over 90%, numbers over 99% of anomalous behavior is behavior that is benign. So I need that third level of AI that will give us the ability, in ML, that will give us the ability to discern intent. And that is the big differentiator for our technology. One of the big differentiators for our technology is the ability to actually discern malicious intent so that when an incident actually hits the SOC has confidence to know that this is something that I need to be concerned with, and it's sophisticated enough to be able to capture reconnaissance activity. Not just that there's an active attack going on, but this is user who's poking and prodding, looking for holes. The last piece we've already talked about a couple times. When we discover things, bad posture, when we discover a malicious user doing reconnaissance, what can we do with that data? Obviously, there's the obvious threat protection part of it, where I'm going to send a block to let's say the AWS WAF. I'm going to open up an incident with my security team in the SOC. But what can we do to ensure that we're actually building better APIs and more secure APIs? So another part of this platform is the ability to essentially use AI to write prescriptions on how to fix, everything that Matthew, you were talking about before that you had to do in a manual fashion in a lot of cases. This is where the ML comes to life, and basically, we'll write prescriptions to the developers in Jira, GitHub issues, Gitbucket, wherever they're convening, to say, hey, there's a vulnerability here or a risk of, a denial of service with this particular endpoint with these conditions. This is how you fix it, and in plain language that they can understand without actually having to click through and do their own investigation in a security tool. So that is a big differentiator for us. The other piece is enriching everything that we find, not just to the developers, but to the testing technologies as well, enriching the DAS technologies with business logic insights and OAS analysis and OAS documentation, anything that will actually help for better testing, to say, hey, did you know about these APIs? You have to test them, and here is how you should be testing them to get better business logic coverage. Okay, so that brings us to really the better together side part of this. We've talked about, since you talked about the AWS WAF and what it's capable of, I spent a bit of time here talking about the SALT security platform and its role in the world from an API application layer security standpoint. And what I wanted to do here was just talk a minute about the strength of bringing both of these technologies together and the integrations, and why we went through the WAF Ready program and the value that it actually going to bring customers. First is on the left-hand side, is on the discovery side. When SALT does identify an API and that expanding attack surface, one of the questions organizations typically ask is, how do I ensure that everything I need to be going through the WAF is actually going through the WAF? We're a great technology to help with that discovery and doing it at scale, so that we can create that inventory, so that organizations can keep track of what is going through the WAF and what's not going through the WAF as a first line of defense. Also, if I want to address any posture issues, again, we can build dynamic rules, or you can build rules based on the findings in our discovery and our posture discovery, to be able to make any accommodations there, or with other AWS components as well as in the ruling in the API gateway, incognito, and other places. On the right-hand side here on the threat protection, I talked about before this ability to use ML and AI learning and technology to be sophisticated enough to identify when an attacker or a malicious user is even doing reconnaissance against an API. Or if there's an active attack, a scripted attack campaign that's going on at a business logic level that's getting through the frontline defenses. What should we do? How do we block it? So obviously I mentioned before this notion of that information can go to the SOC, but one of the great parts of this integration is, without thinking, you can automatically have SALT send a block command with context to AWS WAF to basically thwart the threat right before anything bad happens. I shouldn't have to wait for 10 million records to get lifted before I put a block in place. I should have the ability to tell AWS WAF, hey, there's an issue here. We need to block this user. It's a bad user. They're doing reconnaissance against our APIs. I want to stop them before they find something. The second or the third part here that I wanted to bring up is this notion of remediation insights and virtual patching at the WAF. And Matthew, you talked a little bit about that before, and Sanchit did as well, is if I see something, if I identify something and a threat, let's say in production, right, there is a business logic rule I can write that I can put inside the WAF, right? So if I see that if a user, if I'm not, if a user is logging in with a JOT token and they're changing a cookie parameter to somebody else's username, they're getting somebody else's data, I can actually put a WAF rule in place that basically says, with these remediation insights, to basically say, hey, make sure these two elements of the request match each other, or this is now a business logic violation that I want to block immediately. Again, so the developers will be, maybe taking weeks or months to fix this issue. They have a lot of other things to do, but we can virtual patch at the AWS WAF to thwart the risk and lower the risk until, or patch the application vulnerability until the developers get to it. What I wanted to do here on the last slide is really talk and just highlight a little bit about the moving pieces of the two technologies in play. And I talked a lot about this before, but from an architectural standpoint, as I mentioned before, everything that we've talked about today has to do with inspecting data, inspecting API traffic. And from a SALT standpoint, this is a non-inline solution. It is an asynchronous technology solution, and it's really agnostic in terms of wherever the workloads are running or whatever AWS components that you're using. So we have the ability to integrate and see traffic feeds from one or many places, including the AWS gateway, various places where the different workloads are running, whether they be containerized, whether they be traditional EC2. We can integrate with other edge, CDN, there's CloudFront integration, there's traffic mirroring integration. We have specific ALB integrations that we can do in the AWS environments. And when we capture that traffic, as I mentioned before, there is this notion of metadata extraction. We don't want the raw traffic, we want the descriptions of the traffic. And that is essentially what our cloud ingests. We have a component called our hybrid server or connector. What this basically does is inside your AWS environment, we'll do the metadata extraction there, because a lot of customers are concerned with the fact that I don't want to send you, SALT, my raw request response data to do the metadata extraction there. From compliance and regulatory standpoint, I can only send you metadata. So this is a hybrid component that can run in an organization's AWS environment. Virtual appliance workload can also run inside EKS. As I mentioned before, when sort of bad is detected, from an ops and management standpoint, we'll really integrate with whatever organizations are using. But today we're working on integration with AWS Security Lake and also with the AWS Security Hub. And I already mentioned today the certification that SALT already has, integrating directly with the AWS WAF to send block and rule commands that way. And actually related to this, Matthew, from your standpoint, any particular trends that you're seeing from an application architecture standpoint? Is it everything? And for a while we had these big transformation projects, everything moving to EKS and containers, and then we saw that roll back a little bit where people are like, no, I think we're going to stick with EC2. Is it all over the place still? Any particular trends you're seeing that you're in more environments than others today where the workloads are running?
I would say it's very workload specific. I wouldn't say that there's any trends per se that I see a lot of. I do see, in my particular practice, I do see a lot of API development. And so at the same time, I work with the incident response teams a lot, and I work with the data governance teams a lot. And so let's see if we can go back to that first slide where we had the different layered security models. Because I want to speak, when you look at logging and when you look at testing and when you look at these WAF, you see what you find is that they're good at certain things, but when it comes to API security, they're just lacking in small ways. And so what I find is that when we have a tool like this, we're able to, instead of having a bunch of logs somewhere, we have logs that have already been looked at, for instance, by SALT or some other machine learning language. We have WAF enhanced with dynamic capabilities after we have a tool like yours. And so we gain more capabilities and more visibility, and they're just areas. This is just an area where we really need some enhancement in order to cover this API issue. And just to talk about the data governance, what people don't realize is that APIs that's where your data is put into flight. And one of the capabilities that many enterprises struggle with is that question: how is my data put in flight? How is it moved? How is it accessed? And it's really one of the hardest things to fully understand in terms of scope. So with a tool like this that's able to look at the metadata, as you said, it's able to look at those feeds. We're able to discover which APIs are exposing what types of data and verify that the API is exposing the intended data and not the intended data plus a little bit more. So you know, a lot of times developers don't narrow scopes like they should. So what I'm saying is, this is more than just an incident response tool to help it's more than just a tool to help your developers. It can also be a piece of your data governance tool. And it enhances each one of these pillars here, or areas or layers of security that you see. And, you know, with a tool like this, it's really helpful to have that extra layer of visibility and capability built in. So in my practice, I work with these particular layers of security, but I also, you know, the enterprises struggle with really making these pieces perform in the way that they would like to perform. And again, with the machine learning capabilities behind us, we come closer to solving this problem.
That's good insight, Matthew, and I agree with you. We see it the same way, and we're, you know, from a SALT perspective, we're in a situation because we have all this context that we have the ability to enrich, like you said, not just the WAF, but the whole broader security ecosystem. And, you know, we've been focused on a lot of integrations, and we're going to be announcing a lot of other integrations with other technologies, including some of the AWS technologies I mentioned earlier before. So we're really excited. And I agree with you. I think one of the big issues has always been their organizations are struggling to maintain that, you know, that API governance, security governance. Where does that live? The 10 commandments of developers, thou shalt not, when they build their APIs, and how do we enforce it? So yeah, completely on board with that message. Wanted to cycle back here. We're going to be closing up the presentation here in a couple of minutes, and before I take a couple of questions here, I just wanted to remind folks that the SALT AWS brief, if you're in the presentation, you can, and watching live, you can actually download that in part of the viewer platform here. For those watching this presentation on demand, you can actually go to salt.security, and you can get information about the integration, the AWS partnership, all the different areas in which, you know, SALT and AWS sort of play together, and where we're integrated, and more about sort of the company's strategic partnerships, as well as get access to that same AWS and SALT solution brief there. So that said, let's take a couple quick questions. And so one from Harish here. So Sanjeet, there's a question that's coming up that's asking, how are you seeing AWS WAF adoption? Is there any trend? Are you seeing usage increasing more and more? And the second question is, does AWS provide best practices to help us ensure that when an API or app comes online, the WAF will be in front of it? So, you know, two questions there about sort of the trend of where you see AWS WAF and adoption there, especially with a lot of the new features and functions that are coming out. And then, you know, how have you been, we talked about sort of our discovery from a SALT standpoint, but as a practice standpoint, when you're deploying, does AWS actually provide guidance on, you know, how to make sure that when a new app comes online, that the WAF's in front of it?
Great question. And to address the first question, the trends that we're seeing is with organizations. I think almost all any organization that has a publicly exposed or publicly available endpoint or application deeply care that they need to have a WAF. That's pretty much a given in any shape or form. It could be an appliance or it could be cloud. Cloud is more scalable, and you can integrate more services into that easily. But the trends that we're seeing there is around API security specifically. We do get a lot of questions around customers like, I'm not too familiar with how to protect my API endpoints, what kind of rules, because a lot of the times OWASP or these pre-made lists are not sufficient. They're a good start, but they're not fully covering all the business logic, that we have addressed so far. The other one is around bot security. So specifically around, slow scrapers or automated bots, intelligent bots that evade detection. They can be scraping against your API endpoints. So there is a lot of demand for these two areas, specifically API and bot protection. From a best practices point of view, AWS security team constantly updates recommendations. We have a lot of guides. There are a couple of guides, specifically one around designing or how to build your protections using AWS WAF and related services. So there is a best practices for designing applications and how to protect them using WAF. Those come from best practices and more of taking a very holistic view of every aspect of your application and workflow. And the other one is around DDoS resiliency and how you can actually structure your workloads and infrastructure either from like a multi-region deployment or using these other services that can protect against DDoS attacks. So those are the couple of, one is the trends that we see, and then AWS has a lot of resources in best practices around security.
Yeah, and to build on what Sanjit just said, at a high level, AWS does have a well-architected framework to make sure that you're building your cloud infrastructure and your cloud governance pieces out correctly and holistically and fully. We also have a security reference architecture, which helps you to choose a solution or a service or a technology that AWS has and understand how you need to build the rest of the security architecture around it. And all of those things said, really, it's very important for the organization itself to have a very good cloud governance within itself, because you can have a well-architected framework built around security reference architecture using the tools such that Sanjit was talking about, but you can also have a department that has created their own accounts and set up their own systems that you may not know about. So it's important to have good cloud governance within the company in place as well.
Great, thanks, Matthew. That's good insight. Another question came in, and I don't know, Matthew, if you want to take it, I'm happy to take it as well, but I'll throw it to you first. From Amy, my colleagues think attacking APIs is rare and difficult. How can I shine a spotlight on the issue and explain that hackers are doing this today? Do you want to take a stab at it?
Well, in my mind, I have one statistic that I can think of right now. API attacks are up over 400% over last year. It's not rare. It's not difficult at all. If it's public and you've got Postman, which is it's a tool that's used for API development, you can perform any operation you want against any API, and even authentic, quote unquote, what you think may be an authenticated API. So in other words, you have to authenticate first to get to that API. So it's not a difficult thing to achieve, and the tools are readily out there and free. And there's lots of YouTube videos showing you exactly how to do it step by step.
Yeah, one of the things that always struck me is the breaches and the sort of the post-mortem analysis of the breaches really show, to your point, Matthew, a lot of these attacks that we're seeing are not very sophisticated in terms of the vulnerabilities that they're taking advantage of. Even some of the things that we saw recently on how attackers were able to essentially remote start cars just by walking out and getting a VIN number off the it's pretty amazing how low a lot of the the hurdles were for the attackers to actually get access to the vehicles. I'm always amazed by that. But again, this is the problem with business logic vulnerabilities. They're very easily overlooked.
Exactly, and it's hard to find those business logic vulnerabilities. But and we're using here in this case machine learning, but attackers have also the same tools. They use machine learning to probe and create machine learning scripts to find the business logic flaws within APIs. So we need to up our game. If they're using machine learning to create these attacks, we need to do the same to defend against them.
I think we have time for one more here, and then we'll wrap up. Question from Jeff: when it comes to API security, where does testing fit in, and shouldn't we be starting there? I'll take a stab on it first, and you guys can jump in here. I'm a huge proponent of testing. I think you need to test. I talked a little bit before about some of the problems with testing is that there is just not enough context to be able to capture business logic vulnerability in testing cycles and automated cycles that we're seeing today. Again, that statistic was 20 to 30% app logic permutations is what's tested. The other problem with testing is if I say I'm going to double down and I'm going to focus on testing, it's always abrasive. It's very difficult. You have to find the right technology that fits with your pipeline and your culture. That's why there's all sorts of testing companies that are out there right now. And I was just at RSA, and there were so many talks about nightmares of shift left and how to shift better, and organizations who are pulling things out of the pipeline because developers are afraid to click, check in or submit their code because of the feedback that's coming back in their build process. So it is very abrasive. It takes organizations typically 6 to 8 months before testing and any application, you're getting good value there. I was just working with a customer recently who was telling us they have over a catalog of over several thousand financial institution applications, API-based applications that they have to bring into their testing pipeline. And it's taking them about one application a month to onboard into the pipeline to be able to do this in a way that does not cause a lot of friction and pain to the developers. So it's important, but from my standpoint, I'm also a huge proponent of I need to maximize risk quickly with the least amount of friction, and I need to have that safety net. And that's where the ML/AI-based behavioral runtime protection will give you that while I'm making everything better on the left-hand side. Again, because it takes time to do that, but I need protection today. I need to reduce risk today. Looking at the time here, we are out of time. So Sanjit, Matthew, I am psyched that you guys were able to do this today. So I really, really, really appreciate it. As I mentioned before, if folks have time, you want to learn information, go to salt.security or talk to your AWS or Salt rep for more information. I appreciate you taking the time out of your busy lives to watch this and take part of this today. And bye, everybody.